Okay, so the first thing I want to do is go ahead and test these FETs and make sure that they are matched. Attention static sensitive. So let's get these out of the way and see if I can push the pin out. Maybe. Oh, come on. Where are you going to be like that? Oh. There we go. Okay, so I'm just going to lay these out on my anti-static mat. Hopefully they will peacefully cooperate. I always buy extras just in case. And the last two, oh, there we go. It doesn't really matter where I put them. So I haven't used this in a few days. So 3.76 nanofarads and a turn on voltage of 3.75 volts. So what I do is I just write it down here. Trying to keep one hand on the mat at all times to avoid static discharge. 381 and 3.74. Should have taped that down so it doesn't move around. 3.77 nanofarads and the voltage of 3.76 volts. .81 and 3.89 volts. I don't think this is a supercritical application or they need to be perfectly matched, but I'd like to try to get them as close as I can. 3.81 and 3.89. .82 and 3.92. Don't know if you can see me writing on those or not. .82 and 3.92. So there is a perfect match right there. So I'm going to stack those two together. .383 and .387. So as you know, I always try to order spares, 3.81 and 3.90. .83 and 3.93. And the pinout is gate drain source as you're looking at the front of the transistor. Incidentally, I don't know if you saw it on the bag, but these are the 26NM60N FETs. I believe they're either exact replacements or as close as I could possibly find. So I'm going to go ahead and just take a quick look-see here. These are pretty doggone close right here. 3.81 nanofarads and 3.89 and 3.90 volts. Those are pretty far off. Here's another 3.81 and 3.89. Stack those guys together. I'm not really too terribly concerned about the capacitance, more about the turn-on voltage, but I think we'll go with that set right there. So I'm going to go ahead and drop these guys back in here. Trying to always keep one finger on the anti-static mat, just in case. And we'll pop the pin back in it there. So I'm going to go ahead and move these out of the way because those are the ones I'm going to be using. And we'll put those safely in a drawer for future use. Next, these are not critical in the least. These are the damper or snubber diodes. I got 20 of them just to have them. These are UN 5404 diodes, exact replacements. I don't know if I should have gone up with them. They are 400 volt 3 amp super fast recovery diodes. Yeah. So we'll unplug that and I'll get 2 test leads. Colors really don't matter. I just want to test a couple of them and see what they test like. Now, I don't know why they had these in the anti-static bag because I don't believe these are static sensitive in the least. 553 and 72 picofarads. These should be pretty doggone close because I think they are manufactured virtually at the same time. 550 and 72. 553 and 72. Yeah, I'm perfectly happy with these. 554 and 70. Okay, I'm just going to say they're going to be good. We're going to use 2 of them, and these are the 2 on this end that I tested. I guess I should get a Sharpie. There we go. So we know for sure those are good diodes. I'm just going to tear these apart. Probably should have used scissors. Wow. Okay, there we go. So I got my 2 diodes. I've got 2 matched FETs. Let's go ahead and throw these things in the board and see what's going to happen. Okay, so here's how they are mounted on the heatsink as it stands. And they have some thread lock on them. So I'm going to take a cotton swab and just try to soak that thread lock a little tiny bit to try to soften it up if I can. This will help it come apart a little tiny bit easier, I hope. Hopefully it's not Loctite brand red thread lock, because that is the kind that does require heat. Okay, it is moving, so I'm just going to impact these things out. Hopefully they will cooperate peacefully. Oh yeah, it didn't even need to hit it with the impact one time. Oh, very nice. Very happy with that. Set those out of the way. You know, look at that. It's even got a little insulator. Now we'll see if they'll let go. Yes. Okay, perfect. So these do have ceramic insulators to lower the capacitance because they run at such a high frequency. And those things are stuck pretty good to the heatsink, so I'm not going to try to disturb those any more than I absolutely have to do. Let's just go ahead and test them. We'll get the 168 back out. One of these is going to be dead short, as we saw previously. .77 nanofarads and 3.41 volts, so that one does test good. Obviously, this one's going to be a short. So it should read like two resistors. 0.69, 0.36, and 0.66 ohms. So yes, it is bad. I'm not sure what that is. I know that if you short these out, it will give you some weird readings. And hopefully I didn't just blow up my MK168. So it's doing some tests. Test 4, isolate probe. So we'll take those out of there. Hopefully it ends soon. It's on test number 7 right now. Is it going to finish? Or do I have to reset it? That's just... it seems to be stuck. Well, we'll come back to that. Okay, it finally finished. Let's go ahead and verify that it does actually still work. 3.76 and 3.41. I think it was 3.77 nanofarads last time, but the MK168 lives to see another day. Okay, let's go ahead and mount these things on the heatsink. And I'm going to get just a tad little bit of compound here. Hopefully it's still in view. So as you can tell, I did get these from Mauser. They're not a cheap Chinese import or anything like that, which I know we've had problems with in the past. But sometimes that's all you have available. I wonder if I can wash my anti-static pad in the dishwasher. The nuts are stuck together. I hate it when the nuts get stuck together. Okay, and I'm going to just... I know I have a socket that'll fit this, but... I'm not putting final torque on these yet. I want to make sure that they are aligned properly, straight up and down as far as I can get it. There we go. I think that's pretty doggone close. Happy with that. And click. They are torqued to spec. I'm not going to put more thread lock on it. I don't think they're going to go anywhere, honestly. Okay, we have one diode out of the board already. So I'm going to keep this on the anti-static pad. Just going to set it up here in the corner out of view. Actually, you know what? I'm going to set it so the leads touch the anti-static pad. That will ensure static discharge. So I already have the one diode out of the board right there. And as I recall, these things went in the opposite direction of each other. And I always try to, if I'm going to bend the leads, I try to bend them so someone might be able to read the part number at a future date if they need to. I kind of want to stand this up because there are components right underneath it and I don't want any kind of capacitive coupling. So I'm going to stand it up just a hair, maybe a 1/16 of an inch off of the board. And one moment while I turn on my soldering station that I turned off. Let it wake up a little bit and we'll be right back. Okay, we are warmed up. I think I bumped the board so it's not going to be perfectly centered. It might be a small transition. All right, pretty happy with that. Diode is up off the board. And I did dig away some of that glue and I don't see any conductivity portion of it. I'm going to leave it. There are so many little surface mount parts under this thing. But yeah, I would love it if they did not use the stupid yellow glue. There's so many better choices out there. Leads have been trimmed. Now this one's going to melt some of this little pad right here because I am going to change the other diode at the same time. Just for the heck of it. Make sure that we are in the correct orientation, and yes. Okay, diode is loose. I don't think I can lift it. No, well, maybe. Yep, okay, there it is, out of the board. UF5404, same exact diode that's going back in. happy with that, although I doubt you could see it when I flipped it over. It did move very slightly, but I think it's going to be just fine. And then there is the RC network resistor and capacitor that goes across the diode, basically to take away high frequency noise. Okay, so I need to put the standoff back on this. This wasn't even tight, I just loosened it by hand, even though they did put thread lock on that side. Now, if everything is right in the world, these will line up. Just like that. Trying to keep everything plugged in right there. There is a single ground screw. Actually, I don't think it's grounded, it's just a support screw. And interestingly enough, they did not thread lock that screw. And then the mounting tabs did go through there. So I'm going to solder those first because I believe the heatsink is earthed or grounded. And I want to push down on it to make sure that it's fully seated against the circuit board. Same on this one. My dog wants attention, as you can hear. Hopefully you can still see that it's in view. Okay. I am happy with those results. Now we just need to give it some power on that connector right there. And I think what I'm going to do is, because it has these output filters, they are Suscon, so they're suspect. I did ESR them, they both tested fine. I did check the rectifier diodes as well, they all test perfect. These are 470s at 50 volts, so that means the maximum voltage that's going to be created between the HD positive and the HD negative is going to be 100 volts. So what I want to do is, I've got a 40 watt incandescent bulb that's meant for 120 volts. I'm going to attach it from the positive lead right there to the negative lead, just to put a small load on this power supply that I can try to run it out of the circuit. I don't want to try to run this thing unloaded. I don't know what the results are going to be. And then the opto feedback, I'm not quite sure where that goes. That there is an opto isolator, so it may come up in a low power like sleep mode, because it does claim to be Energy Star compliant. So I just want to put a small load on this and try it out of the enclosure first. Make sure that's the common lead between the two filter caps right there that I was using as a reference point for testing. But let me go ahead and just give this circuit board a quick look over and see if I see anything I don't like. If it does successfully power up, then we'll go ahead and just... It looks like someone's been in here before because there's... I mean, I did that, and of course the diode's there, the tab's there, and the diode there. But there's several other, like the optical isolators here. Yeah, they've been hand soldered a couple times, it looks like. Well, let's go ahead and get a power cord and see what happens. Maybe we'll have sparks, and maybe not. I don't know. We'll find out. One moment. Okay, well, as you can see, I have two incandescent bulbs connected. I'm going to go full Shango on this one. This is in series with the AC input going into the power supply. And then this one is connected to the output of the power supply. So what I expect to see is when I power this up, I should see a light on this bulb, and it should start bright and then gradually dim as it charges these two main filter caps right here. These are 820 microfarad 200 volt capacitors. And then if the power supply successfully starts, then I should see light on this one, and this one should actually get brighter as the switch mode power supply tries to compensate for the voltage drop. Well, who am I kidding? If there's going to be a problem in the switching regulator, the power that's going to be stored in these capacitors is going to be more than enough to blow up anything down here. I've got my variac set on 120 volts. Input light bulb, output light bulb. Let's just power it on, see what's going to happen. Look at that, the power supply is starting. So I think I can connect it directly now because you did see this light light up. And what it's doing is it's dumping the power out of these capacitors through the switch mode power supply. And then this light is not, it doesn't have enough, it has too much resistance. So let me dig around under my workbench for just a moment. And I have a couple of incandescent 200 and 300 watt bulbs. So let's go ahead and put the 200 watt in. Yes, you can still buy incandescent bulbs. I bought these about 3 months ago at the local hardware store. Lowe's or the Home Depot, I'm not sure which one. So let's go ahead and put in the 200 watt incandescent. $200 watts, 3,305 lumens. Might be kind of hard to see there. There it is, 120 volts. These are not rugged duty lamps in the least, but I should see a very dim flash on this one, and then this one should start and stay lit, hopefully. Here we go. Please don't blow up. And I'm going to raise the voltage. You can just barely see the filament glowing in this bulb if I shut the lights off. So the power supply is running. It is producing voltage, and we're pulling about 55 watts right now. This is actually a 60 watt incandescent bulb. So I'm going to reduce the voltage down, and I want to see that lamp. I'm not sure why it did that. But it did start up. Maybe it doesn't like low voltage. As you can see, this thing was definitely getting bright. So there's a possibility of a brownout situation may cause problems on this. And I'm feeling the heat sink. It is ice cold. Output filter or output rectifier diodes, ice cold. So remember, we are dropping voltage across this bulb right here. So as I increase the voltage, the current is actually going down and this bulb is becoming dimmer. So I'm pretty happy with those results. I'm going to let it sit here and cook for probably an hour or so before I do anything else, just to make sure there's not some weird problem with this power supply. I'm going to leave the input bulb connected as well as the output bulb connected, And oh yeah, incandescent bulbs, they get hot. I forgot about that. Even this one's barely glowing, as you can see right there. And the glass is becoming warm, but let's sit here and cook for a while. It's about 45 degrees outside right now, so it's going to warm up my room a little bit. We're not running the heater quite yet. It's probably 65 degrees in the house. I don't quite feel the need for the heater yet. When it starts hitting the 30-degree mark outside, then we'll run the big furnace in the house. So I'll be back in probably an hour. It is currently 11:53 at night, and you can see it is Sunday, January 28th, 2024. Okay, well, I kind of missed the mark on that one. It's 1:15 in the AM on January 29th, 2024. And I did bring a secret weapon. This thing has been running for a little over an hour now. I do have my infrared camera set up here, so I'm going to hit record. Okay, infrared camera is actually recording this time, unlike the last two takes. So heatsink temperature, 125 degrees. That's the center spot, number 1. And there is something running a little bit warm over here. And it appears to be that little transistor at 162 degrees. Keep in mind there is no air movement on this power supply board. Normally when this is in the enclosure, you're going to see as the woofer moves in and out, it's going to take in fresh air and exhaust the air back out because of the vented design. What do we got down here at 200 degrees? Wow. That is another little transistor, 214. But once again, as the air moves in and out, it's going to cool it. I'm just going to blow on it for a second. And we got it down to 189 degrees that fast. So I think once this thing is powered up and moving some air around, it's going to be just fine. Once again, this is in a static situation. There's no air movement in this room at all. Just for reference, the lamps over here, 283 degrees I saw on the output lamp and 190 degrees on the AC input lamp. Shango style. Okay, enough of the infrared camera. I do have my kilowatt connected, currently pulling 50.8 watts. I did up the AC input voltage so that the power supply is receiving 125 volts of AC. Let's go ahead and unscrew this hot bulb, which is really only hot on the top. I just want to see what the idle current is on this. It does claim Energy Star, and at 2.2 watts, it might actually make that qualification. I thought it had to be 1 watt or less, but I could be mistaken. 2.2, 2.0, 2.2. So I'm imagining the power supply is probably actually pulsing on and off very, very quickly right now as it goes over and under voltage. 1.5, 1.3, 1.4. That's not bad. Connect the lamp again. And we're pulling 48 watts. 49, 50. I think before it was what, 50.9? Something I would expect. But as far as I can tell, everything is working perfectly. Once again, static air situation, no cooling whatsoever. Once this thing gets pumping, it's going to cool this thing off. All right, next step, we got to put this thing back together. Okay, so I do have the power supply mounted back in its cage, and then I have the cage attached to the bottom of the unit, and as you can see, as the air moves, it is going to flow through this thing and keep it nice and cool. And I think that's what they're kind of counting on, that this thing gets lots and lots of airflow. Okay, so I did go ahead and reassemble the power amplifier portion of it with the cabinet on the back. It's got these little rubber plugs that go in here to keep the air out of this chamber for some unknown reason. So at this point, we just got to plug everything in. This goes up to the front panel. It has a 3-digit LED display up there. So we just got to go ahead and plug all this stuff back together. That goes to the speaker, and we'll give this thing a test. Once again, there is the speaker. and there are the two passive radiators, so there's going to be a lot of air moving around inside this thing. And look at the size of that magnet on this thing. Holy moly. And I don't recall, but it looks like probably about a 2-inch voice coil down in there. And this thing is hard to move, so it's definitely going to take some power. I think I tested this on possibly, well, it would have been the second part. Let's just go ahead and test it one more time, just in case inquiring minds want to know. So we'll just go to ohms, and I'm just going to zero the leads out or check them. So I'm seeing between 0.01 and 0.02 ohms. And now I'm just testing at the terminals here. And I'm seeing 3.3 ohms. So that is a 3 ohm voice coil, which is why we only had at the maximum, positive and negative 50 volt power supply. It's intending on putting some current into this thing, as were like the SuperCube 1, 2, 3, and the Trinity, I think had about a 30 ohm voice coil. So it was putting more voltage into the speaker. This one's putting more current into the speaker. But nevertheless, once again, passive radiators on each side, and then the amplifier board basically just sits right there. Okay, well, I have it loosely assembled. I do have only 2 screws in the amplifier portion on the board, and then I have, this thing weighs a couple pounds, only 2 screws down here on the bottom. And yes, I have it on a towel, and yes, I know I put fingerprints on it. I will wipe it off before it ships out of here. So, I do have my audio signal generator fed into this, and I have it set to 250 hertz, which is probably going to be the upper end of its frequency response, because I do see 270 right there. Is that phase or frequency? I don't know, but 270 should be pretty much near the upper end of the frequency response spectrum for this unit. Let me find a power cord, and we're just going to go ahead and power this thing on and bring it up slowly as far as the input level, and because I don't know what the volume control is set at. It has push button volume control, so I don't know if it's max, minimum, in the middle. I would imagine this thing probably has an EEPROM that remembers what the last settings were, or I think it would. So I'm going to set this right at 120, and we'll go 123. So I have my variac set to 123. I'm plugging the AC cord in, and here is power on. And I'm watching the current, and we're at about maybe 4 watts. Oh, look at that. I got a light already. Oh, and I hear something. So I'm curious. I know you won't be able to see it, but if I turn this sideways, volume 26. V26. I assume that's volume. I wonder if I can tip this up. There you go. How high does it go? Oh, it just keeps going and going. Let's get this into focus. Max. Okay, so it goes to 40. You have to press the button each time. So I'm going to set it at 20, right in the middle. And so it's obviously detecting a signal. I wonder what the other things are set to. I do have it on a towel so I don't scratch it. Low pass filter was set at 140, which is okay. And then phase, EQ, there's the phase. So put that on 0. And it was set on EQ1, I do believe. Does that ever go away? Oh, so, oh wow, it changes. I'm on EQ3, and yeah, so EQ must have been off completely, and we'll set the phase at 0. Volume is at 20. Okay, let's go ahead and bring the frequency down. Hopefully you can still hear it just a little bit. Okay, that's a little bit better. Let's put it on the 100 hertz range. All right, there's 30 hertz. It's shaking everything, and this is low level. There's the amount of power I was drawing with the lamp. That is a lot of bass. And that's at 35 hertz. And I don't have anything connected on this. Or screwed down, I'm sorry, as far as the covers go. So, pretty happy with that. I'm going to reattach everything and then give this thing a 24-hour burn-in. And then, hopefully, if everything passes, we'll get it ready to ship back to my customer. Okay, well, there it is, all back together. I've yet to snap the piano black top on it, but I just don't want to have any scratches on this thing. I'm trying to take care down here not to put any scratches on it whatsoever. But let's go and turn the volume up on this thing just a little bit. And of course, I'm at a spot where there's no bass whatsoever. Yeah, those were moving around just a second ago, the solder tips with the bass. The bag is shaking on top of the speaker. The lights up here are rattling. Even on the monitor, you can see it shaking there. But yeah, we're pulling some current. Everything's good. Wish I had a song that had continuous bass. Damn you, Taylor. But anyhow, I think this thing is good. It's been running for almost 24 hours. It is currently 7:06 p.m. on January 29th, 2024. I started this, I can't remember exactly the time, but it was last night or early this morning at probably around 1 or 2 o'clock in the morning. Yeah, it's good. It's been running 24 hours. Not a super loud volume, but you see I did push it a couple times there, and it seems to be working perfectly fine. I did have to crank up the level because I am using the speaker inputs on it right now, just because the ancient Radio Shack receiver that I use up here that you've seen in a video previously does not have a subwoofer out. They didn't know what subwoofers were back in like 1985, but you can see the what was that? The Jurassic Park water effect going on there, and stuff moving around. And the solder tips will move again. And you can hear it moving. Anyhow, let's turn this down. I'll wrap this up. This will be the outro. Well, I certainly hope you enjoyed the repair on the Definitive Technology SuperCube 4000, repairing the power supply board in it. Hopefully this helps someone out there. That is my goal in life, is to help people repair their own products. Go ahead and leave me a question, a comment, a concern down below, good or bad. I do try to respond when I have time, which really hasn't been much lately. Still doing what I can to get caught up as fast as I possibly can, but not a lot of time. Go ahead and leave me a question, a comment, a concern, good or bad. I think I already said that, but I'll continue. You can follow me on social media, Facebook, Instagram, Twitter at NorCal715. You can email me, NorCal715videos@gmail.com. As of right now, until I don't know when I'm going to get caught up, that is not the best way to contact me. Please just leave me a comment in one of the videos, and I do tend to check those more often. Remember, with your help, we can try to keep these things out of the landfill out of the recycle bin and out of the e-waste facility. Everyone, thank you for making it to the end of this multi-part installment. I really, really appreciate it. Everyone have a great day. Once again, thank you so much for watching. Bye-bye. Okay, here we go. Outro. Check, check, check. Let's try to get it on one shot, possibly. Audio sync. Check, check, check. Audio sync. All right, so I missed the mark by a couple of minutes. It's 1:08 in the AM on the 29th, January 2024. And I did bring a secret weapon. I do have the infrared camera, so let's go ahead and cut. Let's take that again. Well, I certainly missed the mark by a couple of minutes. It's currently 1:09 in the AM on January 29th, 2024. So, it's about an hour and 15 minutes. But I brought a secret weapon, the infrared camera. Let's go ahead and switch over to the infrared view. So I just want to take a look at the heat sink right here. And I can tell that it's about 120 degrees-ish. The hot spot's having trouble finding the hot spot. There was one little transistor down here that's running at 158, a little bit warm. And let me see if I can get... So what is that? Oh, that's one of the two diodes, 139 degrees. And can I get to the other diode under here? Maybe. There's that transistor. That's about where the diode is, 131. Main filter caps, pretty cool. 91 degrees. Let's see, switching transformer, about 101. Output diodes and capacitors. Now, can't get an accurate reading on that capacitor because it's aluminum on the top and it reflects the light from the video lights that I have. I'm not too terribly concerned with the temperature on this because it's actually sitting in a static state. So when this is in the subwoofer, it's going to be generating a tremendous amount of bass, which means a lot of airflow moving around. And so just sitting here static at 120 degrees, I'm not too terribly worried about that. And then here are the lamps, 282 degrees on that one. And then, wow, 191 degrees on the AC input cap. Well, next step, put this thing back together and we'll see what it wants to do. No, I guess I should hit record, huh? All right, let's take that again. Are you fucking kidding me? Well, I certainly missed the mark on that one. It's now 1:12 in the AM on January 29th, 2024. So it's been running for over an hour at this point. And I did bring a secret weapon, the infrared camera. So let's go ahead and switch over to that. I did add a piece of black electrical tape to this heatsink because aluminum is a low emissivity, so the camera doesn't pick it up as well. When I took my electrical infrared training class, they suggested black electrical tape is very, very close to 0.95 emissivity. So let's go ahead and take a look at the board here and just see what we're dealing with. Mainly concerned with the heat sink itself, and it's running about 125 degrees. Now keep in mind that is with a 60 watt constant load. Of course, I don't think it's a full 60. I think the voltage is a little bit less. But I would not expect a constant 60 watt load on the subwoofer. unless you're playing a 20 hertz test tone or something like that. And remember, there's going to be air movement because as the woofer goes in and out, it pulls air and pushes air, so it's going to get some forced air ventilation. I do, however, see a little transistor over here that is running at 162 degrees, so it's a little bit warm. It's not out of the ballpark. I think most of these things are rated at a minimum of 185, but yeah, it's just designed basically to a price point. Switching transformer, nice and cool. Let's see if we can get that thermistor 110 degrees right there on the center spot. And then let's take a look at the lamps over here. Yeah, 284 degrees at the hot spot. And that's on the output cap. And then this is the input cap, 194 degrees it looks like. You probably can't see it, but I do have the kilowatt connected. It is generating a little tiny bit of heat. But you may not be able to see the display on it. It's in watts. I'm pulling 50.9 watts. It's kind of jumping around as the AC power fluctuates. But if I unscrew the 290 degree bulb, you probably still can't see it. I should switch over to the other camera. We are down to 2.2 watts, 2.3, 2.6, 2.4. So that tells me that the power supply is regulating absolutely perfectly. Okay, well, the next step, let's throw this thing together and give it some sound and see what happens. Are you fucking kidding me? Was not recording. Well, there it is. Audio's a little bit hot right there because of the massive bass, but that's at like a medium volume level. It's only pulling about 40 watts. It is shaking everything. All that rattling. I wish I could show you, but the soldering tips on my solder station are walking away because of the massive bass. It is just absolutely unbelievable. And I don't even have this thing cranked up yet. Wow. This thing's drawing almost no power at all. That is the efficiency of a switch mode power supply. And it's just shaking everything. And it's not even on the floor in a corner, which is the ideal location for a subwoofer. This thing is just unbelievable. Okay, I'm going to set it up and let it run for 24 hours. I'm just going to put in a FM radio station on it and just let it run for a while. And we'll check back tomorrow evening. And hopefully everything is good and we can ship this thing back to my customer. Okay, so I am using the line level or the high level inputs. I'm sorry, the high level inputs. As you can tell, I had some music playing there. I don't want to get a copyright on it, but we'll give just a couple of seconds. And yes, this thing rocks big time. So I'm going to turn off my main speakers. I'm just going to let it sit here and rumble throughout the night and the next day. And then, like I said, we'll come back to it in, well, about 20 hours from now when I start working tomorrow night. This is the power supply board out of a Definitive Technology SuperCube 4000. I'm not sure what the power output is on this thing, but it had a severely grenaded fuse, and it had a shorted FET and a shorted diode. I replaced both FETs and both diodes, did some checks. I did order spare FETs, and I do have spare diodes from a reputable supplier, Mauser. So I've just got it hooked up here. That light bulb is in series with the AC power going in right here. And this light bulb is connected to the output of the power supply. So I'm just bench testing this thing for about an hour before I put it back together, and hopefully it passes the test. Definitive Technology SuperCube 4000. Hopefully you'll see this video upcoming soon on my NorCal 715 channel. So this is the power supply out of a Definitive Technology SuperCube 4000 subwoofer. It came in, it had a shorted FET and a shorted diode. I replaced both FETs and both diodes, and it had a severely grenaded fuse right there. Anyhow, I ordered extra FETs, as I always do, and I do have extra diodes just in case, and I did get them from a reputable supplier, Mauser Electronics. This lamp is in series with the AC power going in right there. This lamp is connected to the output of the power supply. So I'm just like load testing this thing briefly for about an hour. It's been running about 20 minutes right now. The heatsink is getting just maybe 90 degrees or 100 degrees, but it's under a constant 60 watt load right here. I'm not sure what the power output is on this subwoofer. The power amplifier is down here on that board right there. I don't think it's going to be too terribly powerful, but I'm bench testing this thing and will hopefully see it up on my YouTube channel, NorCal 715.